This is FE Peer Review. The date is the 5th of December 2021. Corey Kells 45-degree sector experiment, critical analysis, preliminary, building the Earth model in Sketchup Pro. This video is going to be the first in a two-part set. In this first video, I am simply going to be building in SketchUp the model I am going to use to do the analysis in the second video. Bob, the science guy on his Research Flat Moon channel, did an excellent debunk already of the video I'm going to be looking at. The gentleman's name is Corey Kells, and he's got something he calls the 45-degree sector experiment or something like this. He is it's full of geometric mistakes. The guy basically can't visualize 3D space or handle geometry in a 3D context, and so his experiment, his so-called test, is a geometric flop. Dr. Bob did a really fine, full analysis of all the problems. However, I thought I would do one as well, with the focus being on a graphic visual approach, as I've done in some of my other videos. I thought that might be helpful for those of us who find that kind of approach to a solution a little easier to grasp. So that's what we'll be looking at, the construction of the model in this video. I've run through the construction process at double speed. I sped things up by 100% and narrated over it, explaining how I built the model. In the follow-up video, I'll be doing the actual analysis of Corey Kells' quote experiment. So I'm building a sphere in SketchUp. SketchUp is a great tool for architecture, very useful. It's not really intended for building things like this of this scale. I'm building my Earth sphere at a reduced scale. I've made 1 meter equal 1 kilometer, so that's 1/1000th. And SketchUp is a little bit crude with curves. It doesn't actually do curves. It approximates curves with tiny straight lines. And you can tell it how many to do. So I made a circle, and I told it to make the circle out of 180 straight lines. So each line represents 2 degrees of the circle. So it's a very slight approximation because of that. It gives me a sphere that's actually made up of thousands of small flat faces. But enough about that. What I'm doing here is I've made a half circle, and I'm going to rotate it around its axis to generate the actual spherical surface. So I'm putting in some little markers that I'm going to refer to later that indicate the tropics and the Arctic and Antarctic circles. That's what this is all about here. I'm running this video at 2 times the actual speed. I modeled it at half the speed, so if you want to see it real time, you can slow the video down by 50%. And I may decide to snip out a little bit here and there, because I made some false starts and had to back up in a few places. And there's no point in you guys seeing all that. Okay, so I've made some planes, some flat square planes, and these planes intersect that arc at the tropics, at the equator, and at the Arctic and Antarctic circles. And the reason I've done that is because I want to create a clear imagery on the sphere that shows where those circles are on the sphere. And so here's the way to do it. I'm generating the sphere now with this half circle following the path of the little circle below it. It'll rotate around that path, and it takes a little bit of time because there's a lot of math for SketchUp to do here. There you go. There's the sphere. And now I'm going to move those square planes back over. And where each plane intersects the sphere, I can do an intersection command that leaves behind a line where the planes intersect. Okay, that went by pretty quick. That's all right. Now I've got 4 of those spheres, and I've arranged them around a central point to indicate the 4 seasons. And I've got the sphere tilted. I think I tilted it 23.43 degrees, if I remember right. I approximated, by the way, I approximated the latitudes of the tropics and the Arctic and Antarctic circles. I rounded to the nearest 2 degrees, so 24 degrees, just because the sphere itself was made in 2-degree increments and I wanted to be consistent. However, when I rotated the sphere relative to the orbital plane, I did that at 23.43 degrees. Now I'm just checking it to see if I'm happy with the results. So we can see the Arctic Circle at the top, the Tropic of Cancer, the equator, and a little glimpse of the Tropic of Capricorn down below. And we have a sphere that's tilted in the direction for spring in the northern hemisphere. Now, when Sketchup does these curves, it hides the little edges that it creates in order to give you the view of a smooth surface. So what I'm going to do here is I'm just going to unhide them so that you can see the actual edges. You can see the 2-degree increment lines there. That's what I'm pointing at with the mouse. And I'll turn them off again because it's not really necessary right now to see all that. It just makes it look a little too busy. I just wanted you to see that the geometry is all in there, but sometimes some of it remains hidden. Here I'm just pointing out the axial tilt relative to the orbital plane, 23.43 degrees. I've moved 3 copies around, respecting that same tilt so that we have representation of the 4 seasons. And the center of the sun, that distance is not to scale, of course. I didn't make that to scale. I don't really need it for the demonstrations I'm going to do. It would have set those spheres, way too far apart in the model to be able to see them all in the same image. Okay, I've got the model done. So I've made 4 copies of the sphere. They are tilted 23.43 degrees to the orbital plane so that we have a northern hemisphere summer, southern hemisphere winter model on the right. We have the reverse on the left, and then we have 2 equinox models. I've got each sphere, it has Antarctic and Arctic circles, tropics, and an equator. And then the pins are located at 50 north, latitude 40 north, the equator, and 30 south, which provide useful reference points to locations in Northern Europe, the United States, the continental United States, Australia, and of course the equator. I've set 4 groups of these pins around the sphere so that we can look at different times of day easily. The pins themselves are perpendicular to the surface of the sphere where I've placed them. As you can see, the lines all converge to the center of the sphere here. So that'll give us a local zenith from which to measure our angles. And what I'll be doing with this is in the following video about Corey Kells and the 45-degree sector experiment, or whatever it is he calls it, we will use this model to look at some of those angles. And maybe we'll also compare it to the information we get from websites like timeanddate.com. So that's coming up next. Hope you enjoyed this video, seeing how I made the SketchUp model. If you did, please do like and subscribe. I'll be using this model in future videos as well, I expect, because it should be quite handy. Remember, like, subscribe, and leave comments, etc. Bye-bye.